Everything you know, Earth, the Sun, even atoms themselves, will eventually be erased. Imagine pressing play on the greatest time machine ever built. The hum of its engines fills the air, your heart races, and in that instant you realize you're about to witness the ultimate story of existence. Not just the fate of Earth, not just the destiny of humanity, but the unfolding of the entire universe itself. This isn't science fiction. It's a journey through time, billions upon billions of years ahead. A journey where stars die, galaxies collide, and even the very building blocks of matter face their end. Now, let's set the stage. We are not just talking about tomorrow, or even a million years from now. We are talking about 10 quintillion years into the future. That's a 1 followed by 19 zeros. A number so vast it almost feels meaningless, yet it represents the unimaginable scale of cosmic time. But before we get there, let's take it step by step, starting with something closer, 1 billion years from today. Globe showing Europe Africa 1 billion years ahead. Picture Earth, the vibrant blue marble we call home. Oceans shimmer, forests breathe, and life thrives. But fast forward 1 billion years, and that same planet is unrecognizable. The Sun, our life giver, has been slowly heating up, about 1 degree hotter every 100 million years. By this point, Earth's average surface temperature has soared to 47 degrees Celsius, 117 degrees Fahrenheit. The consequences are devastating. First, plants collapse under the heat, disrupting the carbon cycle. Then animals vanish. Oceans, once teeming with life, evaporate into the atmosphere, leaving behind a barren, cracked surface. Earth, once a paradise, becomes a lifeless desert rock. And what about us? Humanity's survival depends on leaving Earth long before this point. Colonies on Mars. Too close to the Sun. We'd need to move much farther, perhaps to the outer planets or even beyond our solar system. By then, it's possible we've mastered interstellar travel, scattering across habitable worlds in distant galaxies. But there's another possibility. Some humans may no longer exist in physical form at all. Instead, they've uploaded their consciousness into machines, living virtually forever. These digital beings would rely on physical humans to maintain energy sources, creating a strange coexistence between flesh and code. But here's the terrifying question. What happens when energy finally runs out? It sounds incredible, but it all hinges on one thing: energy. Even today, we struggle to power our world sustainably. Imagine the challenge of fueling civilizations across galaxies. That's why breakthroughs in energy technology are so critical. Without radical energy breakthroughs, humanity's future, biological or digital, simply collapses. Sun with rays #10 billion years ahead. Now, let's leap forward to 10 billion years. The Sun, once blazing with energy, has reached the end of its life. It swells into a red giant, engulfing Mercury and Venus, and likely vaporizing Earth entirely. What remains is a stripped iron core, drifting in space. Eventually, the Sun shrinks into a white dwarf, a dim star about the size of Earth. It will cool for billions of years, fading into darkness. But while our star dies, something else extraordinary happens. Galaxies collide. The Milky Way and Andromeda, two giants of the cosmos, crash together in a slow-motion dance lasting millions of years. Imagine standing in the middle of this merger. It would feel like being inside a shaken snow globe, except instead of snowflakes, entire stars and planets swirl around you. The result? A new galaxy, sometimes called Milkomeda or Mila. Our solar system faces a 50% chance of being flung far from the galactic core, and a 12% chance of being ejected entirely. But by then, humanity, if it still exists, will have long abandoned this region, choosing safer galaxies far away from the chaos. The Milky Way, the galaxy we've always called home, will be gone. In its place, a new cosmic identity emerges. Link symbol rehook, end of part 1. So far, we've seen Earth die, the Sun fade, and galaxies collide. But this is only the beginning. What happens when the universe itself starts tearing apart? What happens when stars stop forming altogether? Stay with me, because in the next part, we'll witness the Big Rip, the death of stars across trillions of years, and the slow unraveling of the cosmos itself. underscore 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 underscore. When the universe starts to tear, the death of Earth and the fading of our sun were only the beginning. But what if the universe itself turns against us? What if the very fabric of reality starts pulling apart? That's where we are headed next, 22 billion years into the future. Underscore 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 22 billion years ahead, the Big Rip. At this point, the universe faces one of its most terrifying possibilities, the Big Rip. Dark energy, the mysterious force accelerating the expansion of the universe, grows stronger and stronger. Scientists don't fully understand it, but they know one thing: it's pushing galaxies apart faster than gravity can hold them together. Now imagine this: galaxies stretch, star systems unravel, planets drift away, and eventually even atoms themselves are torn apart. The universe doesn't just fade, it shreds. But here's the chilling thought: if the Big Rip happens, it won't stop at galaxies. It will reach down to the smaller scales, ripping apart molecules, atoms, and even protons. Reality itself dissolves. And here's the question that keeps physicists awake at night: is this truly our fate, or just one possible ending? Some evidence suggests dark energy could lead us here, but it's not certain. Maybe the universe avoids this catastrophic unraveling. Maybe expansion continues without ripping everything apart. So let's assume, for now, that the Big Rip doesn't happen. What comes next? Underscore 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 100 trillion years ahead, the death of stars. Fast forward to 100 trillion years. Even if the universe survives the Big Rip, it faces another slow-motion tragedy, the death of stars. Think back to the Big Bang. About 150 million years after it, the first stars ignited. Since then, stars have been forming continuously, collapsing clouds of hydrogen gas into blazing spheres of light. But here's the rule of stars: the smaller they are, the longer they live. And massive stars, 10 times the size of our sun, burn out in just 20 million years. They die violently, collapsing into neutron stars or black holes. Our sun lasted about 10 billion years before fading into a white dwarf. Red dwarfs, smaller and dimmer, live far longer, up to 100 billion years. By the time we reach 100 trillion years, even these long-lived red dwarfs begin to die. Brown dwarfs, the failed stars too small for hydrogen fusion, cool into invisible embers. The universe enters the stelliferous era's twilight. Stars are no longer being born. Instead, one by one, they flicker out. Imagine looking up at the night sky. Today, it's filled with billions of stars. But in this distant future, the sky grows darker, emptier, lonelier. And here's the terrifying question: what happens when the raw material for stars, hydrogen gas, finally runs out? Without new stars, the universe loses its ability to create habitable zones. Planets drift cold and lifeless. Galaxies become graveyards of stellar remnants, white dwarfs, neutron stars, and black holes. This is the slow fading of light itself. Underscore 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 underscore. Now pause for a moment. Think about humanity in this era. If we've survived this long, we are no longer clinging to planets orbiting stars. We'd have to invent entirely new ways of living, perhaps harnessing black holes for energy or existing purely as digital consciousness powered by exotic physics. But here's the emotional punch. Without radical breakthroughs, even the most advanced civilizations collapse. Energy runs out, stars die, and the universe itself grows cold. It's not just about science, it's about survival. Underscore 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 underscore. So far, we've seen the threat of the Big Rip and the slow death of stars across trillions of years. But this is still only the middle of the story. What happens when all stars are gone? What happens when the universe enters the degenerate era, where only black holes and fading remnants remain? Stay with me, because in the next part, we'll witness the collapse of matter itself, the decay of protons, and the rise of the black hole era. Underscore 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 underscore. The degenerate era, when matter itself begins to die. The death of stars was tragic enough. But what if the universe itself becomes a graveyard, littered only with the corpses of dead stars and collapsing remnants? That's where we are headed next, 10 quintillion years into the future. 10 quintillion years ahead, the degenerate era. By this time, the stelliferous era, the age of star birth and death, is over. The universe has entered a new chapter, the degenerate era. Look around. The once bright cosmos is now dim, cold, and silent. No new stars are forming. Instead, the universe is filled with remnants. A white dwarfs, cooling embers of dead stars. A brown dwarfs, failed stars fading into invisibility. A neutron stars, dense, compact corpses of massive stars. A black holes, the ultimate cosmic predators. The night sky, once alive with billions of points of light, is now a graveyard. Imagine standing on a planet in this era. The heavens above are no longer sprinkled with starlight, but instead are dark, punctuated only by faint glows of dying remnants. The silence is overwhelming. But here's the haunting question. What happens to humanity in a universe without stars? Even if we've spread across galaxies, we still need energy. Without luminous stars, habitable zones vanish. One possibility is that humans abandon physical bodies entirely, existing as pure energy or digital consciousness. Another possibility? We attempt something even more radical, creating new universes ourselves. Yet survival here is fragile. The universe is cooling, matter is decaying, and collisions between remnants are rare but dramatic. Two brown dwarfs colliding could spark a new star, burning for trillions of years. Two white dwarfs colliding could trigger a supernova. But these events are exceptions, not the rule. Overall, the cosmos is fading. The universe is becoming a place of shadows, where light itself is a rare miracle. Underscore 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 10 decillion years ahead. Proton decay. Fast forward again, 10 decillion years. That's a 1 followed by 34 zeros. By now, even the remnants themselves begin to die. The process is called proton decay. Protons, the fundamental building blocks of atoms, slowly disintegrate. White dwarfs, neutron stars, and brown dwarfs lose their structure as the particles inside them collapse. Imagine watching a star fade not in a blaze of glory, but in silence, shrinking into nothingness. Their brightness dwindles to the glow of a few light bulbs before vanishing entirely. And here's the terrifying anchor. If protons die, what's left to build anything at all? Without protons, molecules cannot exist. Without molecules, matter itself ceases to exist. The universe isn't just losing stars, it's losing the very foundation of reality. This is the slow death of existence. The very bricks of the cosmic house are crumbling, leaving behind only emptiness. Underscore 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 underscore. Think about the emotional weight of this moment. For billions of years, humanity looked up at the stars for guidance, for wonder, for hope. Stars were our storytellers, our navigators, our symbols of eternity. And now, in this unimaginable future, they are gone. The universe is no longer a place of light. It is a place of silence, where the last remnants of matter are dissolving. Imagine civilizations that once thrived, now reduced to whispers of energy, clinging to existence in a cosmos that no longer has the raw material to sustain them. It's not just the death of stars. It's the death of everything. Underscore 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 underscore. Humanity's fate. If humanity has survived this long, we are no longer bound by biology. We'd exist as information, energy, or something beyond our current imagination. Perhaps we've learned to manipulate physics itself, creating artificial stars or even pocket universes to sustain ourselves. But even then, the collapse of matter itself poses a final wall. Without protons, without atoms, without molecules, there's nothing left to build, nothing left to inhabit, nothing left to sustain. This is the ultimate existential crisis, not just the death of life, but the death of the very possibility of life. Underscore 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 underscore. When describing proton decay, add a 2-second silence after the line. Without protons, molecules cannot exist. Without molecules, matter itself ceases to exist. This pause lets the audience feel the weight of that truth before continuing. Underscore 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 underscore. So far, we've seen the universe enter the degenerate era and the terrifying decay of protons themselves. But the story doesn't end here. What happens when black holes take over? What happens when even they begin to die? Stay with me, because in the next part, we'll witness the black hole era, the rise of Hawking radiation, and the final collapse into the dark era.